Welcome. This video explains the IGCSE 0580 Mathematics Circle Theorems in clear, simple steps. We'll use easy examples and diagrams so you can recognize angles, tangents, and cyclic quadrilaterals with confidence. Subscribe to my YouTube channel for more educational insights, and don't forget to press the like button.
To solve problems on circle theorems, you must know the required content for the core and extended syllabuses. For core, calculate unknown angles and give brief explanations using two facts. Angle in a semicircle is equal to 90 degrees. An angle between a tangent and a radius is equal to 90 degrees. Or extended, you must also use additional angle and symmetry results to calculate angles and justify answers, namely, angle at the center is twice the angle at the circumference. Angles in the same segment are equal, opposite angles of a cyclic quadrilateral are supplementary and add to 180 degrees. And the alternate segment theorem, together with symmetry facts. Equal chords are equidistant from the center. The perpendicular bisector of a chord passes through the center. And tangents from an external point are equal in length.
Let us start with the namings first. This is the center of a circle, where all the points on the circle are at an equal distance from this point. Now, if we draw a line from the center to any point on the circle, this line is called the radius. The radius is the same for all points on the circle. If we extend a straight line across the circle, passing through the center, we get the diameter. The diameter is always twice the length of the radius. A line segment that connects any 2 points on the circle without necessarily passing through the center is called a chord. The longest possible chord of a circle is its diameter. A curved part of the circle between 2 points is known as an arc, while a sector is the region or an area between 2 radii and an arc. If a chord divides the circle into 2 regions, each region is called a segment. Now, the circumference of a circle is the total length of its boundary, or perimeter of a circle. Then a tangent to a circle is a straight line that touches the circle at exactly 1 point without crossing it. And a secant is a straight line that intersects the circle at 2 distinct points. Then we use the word subtended to describe how an arc or a chord creates an angle at a point on the circle. For example, when an arc forms an angle at the circumference, we say the angle subtended at the circumference by the arc. Similarly, if the angle is formed at the center, we say the angle subtended at the center by the arc. This completes the basic naming of a circle. Angles subtended by the same arc are equal. This means that if an arc subtends an angle at multiple points on the circle, all such angles are equal. So, this angle is equal to this, and this one as well. Now, if I draw another angle like this one, it will be equal to all of these angles. Now, here's a question. If this angle is 65 degrees, and this angle is 35 degrees, then what will be the value of all of the remaining angles? It's easy, right? This is 65 degrees. So, this angle will also be equal to 65 degrees, because angles subtended by the same arc are always equal. Similarly, if this angle is 35 degrees, then this will also be equal to 35 degrees, following the same theorem. Now, the sum of all angles in a triangle is 180 degrees. Angle at the center is twice the angle at the circumference, which means the angle subtended by an arc at the center of the circle. Or, this angle is always twice the angle subtended at the circumference by the same arc. So, if this angle is 40 degrees, then this central angle will be twice of it, or 80 degrees. But if I draw like this, then this angle will be 40 degrees using the first theorem we just saw. Angle in a semicircle is always 90 degrees, which means if an arc is a semicircle, that is, its endpoints lie on a diameter, then the angle subtended at the circumference is always 90 degrees. Chord bisector theorem. This means that if we draw a line that is both perpendicular to a chord and divides it into 2 equal parts, then that line must pass through the center of the circle. Theorem of tangent and radius. We have already mentioned that a tangent is a straight line that touches the circle at exactly one point without crossing it. The important property of a tangent is that it is always perpendicular to the radius at the point where it touches the circle. The two tangents theorem. If two tangents are drawn to a circle from a single external point, then these tangents will always be equal in length. Another important property of this theorem is that the line joining the external point to the center of the circle always bisects the angle formed between the two tangents. So, if this angle is 40 degrees, then both these angles will be equal to 20 degrees, and if this length is equal to 5 units, then this piece will also be equal to 5 units. Theorem of cyclic quadrilateral. A quadrilateral is called cyclic if all its 4 vertices lie on a circle. The important property of a cyclic quadrilateral is that its opposite angles are always supplementary. This means that if we take any 2 opposite angles of a cyclic quadrilateral and add them together, the result will always be 180 degrees. For example, if this angle is 70 degrees, then this angle will be equal to 180 minus 70, or 110 degrees. Alternate segment theorem. This theorem states that the angle between a tangent and a chord drawn from the point of contact is always equal to the angle that the same chord subtends in the opposite segment of the circle. Same is true for this angle. It will be equal to this angle because this chord makes this angle at the circumference of the circle.
To begin this question, we're going to look at the line ECF, which is a tangent to the circle, and also the line OC, which is a radius. One of the theorems said that a tangent meets a radius at 90 degrees. So we know this angle here is 90 degrees. So let's write that down. Angle OCF equals 90 degrees. Now we're going to look at the whole triangle OCF, this one here. We have 2 of the angles in this triangle. We have the 32 degrees and the 90 degrees, so we can find the missing one. If we add together 90 and 32, you get 122. And if you subtract this from 180, you find the missing angle is 58 degrees. So we can write that angle COF equals 58 degrees and label this onto the diagram. Next, we're going to look at the angle CAB, which is this one here. You should remember that the angle at the center is twice the angle at the circumference. We can see the angle at the center from the chord CB is 58 degrees. So the angle the chord CB makes at the circumference, which is the angle I've marked, must be half of 58. So if we do 58 divided by 2, which is 29, we know that this angle must be 29 degrees. Next, we're going to look at the smaller triangle COB, this one here. Sometimes in questions there's information that's not necessarily marked onto the diagram, but it is useful. It's useful, for example, to notice that OC and OB are both the radius of the circle. This means they're the same length. We can mark that onto the diagram, but it's very often not given to you. You need to be able to spot this information yourself. This means the triangle COB is an isosceles triangle, so 2 of the angles must be the same. So if we subtract 58 from 180, we get 122, and then if you half 122, you get 61. This means both of the base angles in that isosceles triangle must be 61 degrees. The one that's important to us is the angle OBC. So angle OBC is 61 degrees, we can add this to the diagram as well. Now finally, if we look at the triangle ABC, we're only one step away from finding the angle ABO, which was required in the question. So the angle ABO is this one here. All of these 4 angles must make 180 since they're the interior angles of a triangle. So if we add up the angles we have, 40 plus 61 plus 29 makes 130, and if we subtract this from 180, you get 50, which is the answer to the question and angle ABO.
If you liked the content, please share, like, and subscribe to our channel, Global Learners Nexus, on YouTube for more educational insights and helpful resources to guide you on your learning journey. By joining our community, you'll stay up to date with the latest tips, strategies, and expert advice to help you excel in your studies and future career. Don't miss out on the chance to unlock your full potential. Subscribe now and take the first step toward your success. Stay tuned for more.